To find again the limit of the exponential function, we have to recall again the theorem number 2 regarding the limit of the exponential function, which states that the limit of b raised to x minus 1 over x, as your x is approaching, of course, as your x is approaching 0, the result of this one will always be the natural number b. Okay, that is always the result. Meaning to say, when we are going to apply this one in our problem, the limit of 10, the quotient of 10 raised to x minus 5 over 6 raised to x minus 1, as your x is approaching 0, the thing that we will be doing is we are going to align this problem with our theorem that state that the limit of b raised to x minus 1 over x as your x is approaching 0 is the same as the natural number b. So how is that? We have to manipulate or make ramification of this problem, and so that you will notice the numerator is what is that? Factorable. Okay, so we'll make this one to be 1 instead of 5. This must be 1, so we have to factor it out. So that is the same as we have to factor the limit of, we have in here 5, factor out 5 multiplied by what is left in here is the same as 2 raised to x minus 1, so that when we will be returning that one, definitely it will give you the same numerator. And what about the denominator? That is the same as 6 raised to x minus 1. Of course, as your x is approaching 0. Having said that one, let's continue. Now we have the new statement saying the limit, okay, the limit or 5, that is the same as a property of limit, 5 multiplied by the limit, okay, the limit of, we have 2 raised to x minus 1 over your 6x minus 1 as your x is approaching 0. Now notice that we have now in here the simplified form of the original, but we have to look into a factor or a multiplier of this one so that we can come up with this result. So what is our multiplier? Our multiplier in here is always the idea of 1. Okay, so we have to multiply 1, which is defined by x over x. So defined by x over x. Okay, so that is our 1. Okay, 1 is to be multiplied with this statement, which is the 1 must be defined by having this 1 as x over x. Okay, after that one, notice that we are now ready to make ramification of this one. We exchange these two because they are in the product form. So notice that when we are going to exchange that one, it will give you a result of, that is 5, the limit, okay, of we have in here the limit of 2 raised to x minus 1 for the numerator, that is over, okay, we interchange this one because anyway they are in the product form, so that is over x. Now what about the other factor? The other factor is the same as x over, what is that? That is the same as 6 raised to x minus 1. Okay, so that would be our new form. Of course, as your x is what? As your x is approaching 0. Now, having said that one, with regards to the property of or the limit laws, we can distribute the limit. Okay, we can distribute the limit by having now the statement, saying 5, of course we still have the 5 in here, 5 multiplied by the limit, okay, multiplied by the limit of 2 raised to x minus 1 over x as your x is approaching 0. Okay, now another one in here is multiplied by the limit of the quotient of x over 6 raised to x, that is minus 1 as your x is approaching 0. Okay, so notice that with this form, okay, this form is actually the same as now, the same as the form of our theorem, which states that the limit of b raised to x is equal to minus 1 over x as your x is approaching 0, is the same as the natural number b. So with that, we can say now that when we are going to write this one, this is the same as actually multiplied by the natural number, what is our b? 2. Okay, so that is the result. Now multiplied by, what about this one? That is the same as we say that this is the same as the limit or the natural number, what is that? 1 over the natural number 6. Okay, number 6. And so we have now the idea, or we can now multiply them by saying the limit natural number 2 multiplied by 1, that is the same as natural number 2 over natural number 6. Definitely still this is multiplied by 5. Okay, multiplied by 5. And so that, notice that when we have the idea of the logarithm 5, how about this one? That is actually log of, okay, that is actually log of 2, log of 2 with the base e, okay, over, okay, that is the same as log of 6 with the base e. So that is the resulting or converted logarithmic form of this one. Okay, now using now the change of base formula, this one now can be said to be 5, okay, multiplied by that is, we have in here log of 2 with the base 6. Okay, so that is the application of the change of base formula. Okay, change of base formula, wherein if they have the same base, we can convert this quotient into log of 2 over with the base 6. Okay, so that is the converted form. Now to get now the value, you can make use of the, now to get now the value of 5 multiplied by the log of 2 with the base 6, that is, you can make use of your calculator by pressing 5 times log, okay, log with the base 6 and base 6, and of course log of 2 with base 6. Okay, so we have in here now the statement 5 log of 2 with the base 6 is equal to, that is the same as 1.93. Okay, so the result of this one is 1.93, and so that is the final. Notice that in here, when we find the limit of the problem, now we use the idea or the theorem regarding the exponential function. Okay, so we can now say that if that is the result, the limit of 10 raised to x minus 5 over 6 raised to x minus 1, as your x is approaching 0, the limit is 1.93. Okay, 1.93, and so that is the application now of the change of base and the theorem regarding the exponential function. I hope you followed the process in having the limit of the exponential function like our problem. Thank you. Okay, our next example is, allow me to make use of ball pen in writing down the limit. So our next example is, we have in here the limit, okay, the limit of the quantity of the quotient 3 raised to x minus 1 over 10 raised to x minus 1. Of course, as your x is approaching 0. Okay, so what is the limit of the problem? Okay, what is the limit of the problem? Of course, when we are going to have the limit of the problem, we have to be reminded again with our theorem regarding the limit of the exponential function, which states that if we have this form, the limit of b raised to x minus 1 over your x, as your x is approaching 0, the result will always be the natural number b. Okay, the natural number b. Definitely, when we are going to look into the value of the b must be greater than your b must be, so that will be applicable, that b must be greater than 0. Okay, and of course b should not be equal to 1. Okay, should not be equal to 1. So that if we have this condition, now we can apply this theorem. Okay, now again, we have said that in applying this theorem, we just convert the problem into this form. Okay, we just convert the problem into this form. We are using this theorem, okay, the theorem, because as you can see, when we will be using the direct substitution in here, the result will not, of course, show the natural number b, but its result is indeterminate number, 0 over 0. Okay, 0 over 0. Now let's try to get the limit of this one. Again, to get the limit, okay, now we have to think of a multiplier. Okay, we have to think of a multiplier that is the same as we have in here the quantity 3 raised to x minus 1, and of course 10 raised to x minus 1. Okay, as your x is approaching 0. Now what is our multiplier? Our multiplier will always be 1, and that 1 must be defined. So our 1 in here, our multiplier in here is, okay, let's try to have 1, which is the same as x over x. Okay, we make use of x over x so that we can have a denominator of x. Okay, we can have a denominator of x. So that as you can see, we cannot have the factor in here to produce the value of, or to produce the factor which is x. So what are we going to do? That is to be multiplied by x. Notice that we did not yet make use of the limit. Now having said that one, we have now the result which is the same as the limit as your x is approaching 0 is, of course, we have in here, okay? We have in here that is the same as 3 raised to x minus 1 over, you can interchange this denominator. Anyway, they are in the product form, so it will never change the problem. So that is the same as over x, okay? Over x, and of course the other one is x over, that is the same as 10 raised to x minus 1, okay? So yeah, so that is the that is now the resulting limit product of the limits that we have, okay? Now having said that one, we will now apply the properties of limit by saying the limit notation, okay, will be distributed. So we can have now the form, the limit as x approaches 0 of 3 raised to x minus 1 over x, okay? And of course we have in here that is the same as the limit as x approaches 0 is the same as we have now in here, x over 10 raised to x minus 1, okay? So we have now the idea, okay, let's try to make it better. We have now the idea, the limit as your x is approaching 0, okay, as your x is approaching 0 of 3 raised to x minus 1 over x times the limit as your x is approaching 0 of x over 10 raised to x minus 1. Now notice that this statement is the same as this one, okay, the same as the theorem. And so if that is the case, we can now say that the result of this one is the natural number 3, which is the b, okay, natural number 3, okay. So that is the same as 3 multiplied by, what about this one? That is 1 over the natural number 10, okay, the natural number 10. And so we have now that one as the result, okay. We can now multiply, so that is the natural number 3 over natural number 10. Now notice that when we are going to apply now the logarithm, we can transform this one into its logarithmic form by saying that is the same as log of 3 with the base e, okay, with the base e, over log of 10 with the base e. But again, notice that this one is can be transformed into a single logarithmic notation by applying the change of base formula, okay? So if they have the same base, the numerator have the same base with the denominator, we can state now this one to be what? Log of 3, and make the 10 as our base, okay, 10 as our base. So that is the result. Now to get the result of this one, we can apply that one or press that one in the calculator by saying we press this symbol log with the base 10, and of course that is the same as 3, and then after that one equal sign, so it will give you now that is the same as 0.48. So that is the result, okay. Having the result, we can now have the conclusion that the limit of 3 raised to x minus 1 over 10 raised to x minus 1 as your x is approaching 0 will give you 0.48. Okay, 0.48. So the limit of this statement is 0.48. I hope you follow the procedure, and I hope you can solve one or two problem, okay, in your activity. Before we end this one, may I encourage again everyone to please support this channel by clicking the subscribe button and the notification bell, so that should I post again another lesson for your limit or your basic calculus, you will be notified. Thank you and more power.